get started today. So today we're going to be talking about reference angle relationships and basically what a reference angle is. I kind of mentioned it a little bit yesterday, but a reference angle is the acute angle, and we're going to call it theta prime, formed by the terminal side of theta and the x-axis. So whenever your angle ends in quadrant 1, you'll never really have a reference angle, because if you're starting an angle in standard position and it's ending in quadrant 1, this would be our angle of rotation. There's our angle theta. But then it turns out that the reference angle would be that exact same angle. So that's why this image over here on the right shows only quadrants 2, 3, and 4. And the whole idea is the reference angle is the acute angle that goes back to the x-axis. And that's just because what we talked about yesterday was making the triangles. So that's the purpose of a reference angle relationship, is hey, that's the angle we're going to use when we're setting up those trig functions to evaluate trig functions. That's the idea here. Okay, so what we want to do is, for example, one, it says find the reference angle theta, theta prime for each angle. So the first angle is 5 pi over 3. So for starters, I know that 0 is where I'm going to start, and 2 pi is where I'm going to end after a 360 degree rotation, or a 2 pi radian rotation. And I can think about that 2 pi as well as, I'm going to rewrite it as 6 pi over 3. I'm just putting it in terms of pi over 3 because that's what our angle is in terms of. Because 6 divided by 3 is 2. And what I can think about then is 1 pi is over here, 3 pi over 3. All right. And then, so I got to go more than when I'm rotating here for finding my angle. And I want to go 5 pi over 3. I know I'm going to rotate into quadrant 4, and that's where my terminal side is going to be. Okay, that's how I would want to approach this type of problem. If you're not 100% comfortable with radian measures, I'm hoping you can practice them. But remember, you can always try and convert it to degrees. But I want you to leave your answer in radians, though. So you'd have to do a little bit of work to convert it back at the end. So we can go ahead and say pi and pi divide out. 180 divided by 3 is 60, and 5 times 60 is 300 degrees, which will put us in that quadrant 4. But that tells us our angle theta is 5 pi over 3. And then we have to ask ourselves, okay, well, I have to figure out what's the reference angle here. The reference angle is the shortest distance back to the x-axis, so that way I can form my triangle. And in this case, this theta prime, it's a full circle is 6 pi over 3, and I've already gone 5 pi over 3. So how much more do I have to go? 6 pi over 3 minus 5 pi over 3. Or like 6/3 minus 5/3 is 1/3. So 1 pi over 3. That's what my reference angle would be here. Pi over 3. Which you can do that here as well with the degrees. You'd say, okay, well, I went 300 degrees because I converted to degrees. And then I would say a full circle is 360. I'm going to subtract 300. And I'm going to be left with 60 degrees. And then I can go back. Whenever we're looking for a reference angle, a good way to think about it is if we're in degree mode and we're in quadrant 2, we would say you get this 180 degrees, and you're going to do 180 degrees minus theta. That gets me to my reference angle theta prime. whenever you're in quadrant 2. Or it could be pi radians minus angle theta, and that would get me to theta prime. Okay, so 180 minus theta in quadrant 2 would get me to that. We just did an example that was in quadrant 4, and in quadrant 4 what I did was I did 2 pi minus theta, and that's what got me my theta prime. Or I did it with 360 degrees minus theta, which was 300 degrees, and I got my theta prime. So this is a good rule of thumb for every time you're in quadrant 4, you're going to do 2 pi minus, or you're going to do 360 minus your theta to find your reference angle theta prime. When you're in quadrant 3, it's a little bit different. Quadrant 2 is subtracting the 180. Quadrant 3, you're going to want to go back to the 180, so you're actually going to do theta minus. And in this case, you'll say theta minus 180 degrees and theta minus pi radians. And that's how you're going to get your theta prime in quadrant 3. Just because if your angle is 210 degrees, you'd say, oh, 210 minus 180, so my reference angle is 30 degrees. All right. One key thing about a reference angle is it is an acute angle. All right, reference angle is always an acute angle. Or you could say less than 90 degrees. All right, it's going to be between 0 and 90 degrees every single time. You should never have a reference angle that's over 90 degrees. That means you did something wrong if you're trying to calculate a reference angle and it's bigger than 90 degrees. It's a good rule of thumb there. Okay. We're going to look at one more example of reference angle here. We're going to start on the positive x-axis and stay in position. This time we're rotating negative 130 degrees, so it's going to be less than 180 degrees. And there's our standard position. So our theta's negative 130 degrees. And then I have to think about, how do I form a triangle with the x-axis? That's right here. So that's where my reference angle is going to be, theta prime. All right, I'm in quadrant 3, and in quadrant 3, that means I'm going to have to do this method right here, theta minus 180 degrees, because I'm in quadrant 3. So I'm going to say, oh, in this case, it's kind of weird because it's negative 130, so it's actually just something to keep in mind, because if I did negative 130 minus 180, I'm going to get a big angle. But I really want to think about how far away from 180 am I. That's probably the best way to think about this. This one's kind of a weird one because it's like backwards. But the way I think about it off the top of my head is I have 50 degrees more to go to get to 180. Another way you could think about it is quadrant 3. You find a positive coterminal angle, and you're going to get 230 degrees. And you could say a coterminal angle is 230 degrees, and then 230 minus 180 equals 50 degrees. So theta prime in this case is 50 degrees. That's my reference angle. Something else that's really important about reference angles, they're always positive. Always positive. Never negative values. All right? It's always going to be an angle that you're measuring that takes you back to the x-axis. It's always going to be a positive value between 0 and 90 degrees. It should never be a negative 45, a negative 50, anything like that. Okay, something else to keep in mind about reference angles. They're always positive. Okay, those are the key things about reference angles. Acute angles, positive. We should be able to find reference angles in both radian form and in degree form. And if I start a problem in radian form, like problem example A here, I want you to end it in radian form. So even if you convert it to degrees and you found, hey, that's a 60-degree reference angle, you still need to say, okay, well, I need to turn it back into radians and enter it as pi over 3 radians instead. Okay, that needs to happen every single time. Okay. Now, this next part here says these are the keys for evaluating trig functions. And for some basic trig functions, we should be able to evaluate them without using a calculator. And we can do that in 3 steps. And step 1 would be find a reference angle. Step 2 is going to evaluate the trig function for the reference angle. And step 3 is going to be determine the sign of the trig function value from the quadrant in which it lies, in which theta lies, the original angle. And we're going to talk about that real quick here. Basically, in each quadrant, you're going to have sine of theta, cosine of theta, and tangent of theta. So we'll go ahead and write down sine, cosine, and tangent in each quadrant. I mean, I guess technically we'll do it cosine and tangent in different colors here, just to help out with color coordinating. Okay. Now, what happens in each quadrant we're in, it doesn't matter which quadrant we're in. When we were doing yesterday was we were drawing triangles. So, for example, let's say I draw a triangle in quadrant 1. We want to find this xy value. I draw my triangle in quadrant 1. And then I have my angle theta prime. There's my reference angle. And I have to ask myself, what's the sign? And by sign, I mean SIGN, like is it positive or is it negative, of each trig function. And what we know is we know the radius is always going to be positive. The y value and the x value change depending on which quadrant you're in. So for example, if I'm doing sine of theta prime in quadrant 1, I'm going to do positive y over positive r. So that means the sine function is going to be positive in quadrant 1. If I'm doing cosine of theta in quadrant 1, I'm doing positive x over positive r. So cosine is going to be positive in quadrant 1. If I'm doing tangent in quadrant 1, I'm doing positive y divided by positive x. So tangent is going to be a positive number in quadrant 1. Basically, I'm just using these trig functions to determine whether my value is going to be positive or negative in that quadrant. That's what quadrant 1 looks like there. If I were to draw a triangle in quadrant 2, we can see that it's going to change things a little bit. Here's quadrant 2, there's my theta. Here's my xy value that we're going to be looking for, evaluating the trig functions for. The radius is still positive. This time though, the x value is negative. So as you guys can see, if I did sine in quadrant 2 of theta, I do a positive y over a positive r. So sine's still going to be positive. But now if I do cosine of theta, I'm going to do a negative x value over a positive r value, and a negative divided by a positive is a negative. So in quadrant 2, cosine happens to be a negative function. And then finally, tangent in quadrant 2 is going to be positive y over negative x, opposite over adjacent. And that's a positive divided by a negative, that's a negative value in quadrant 2. That's how we determine the signs of these. And we can go ahead and do quadrant 3 as well, and quadrant 4. Here's quadrant 3, right triangle, quadrant 4, right triangle. And in quadrants 3 and 4, we can see that the y value is going to be negative in both of them. In quadrant 3, the x value is going to be negative. In quadrant 4, the x value is going to be positive. And the r value is going to be negative in all of this, or positive in all the situations. So here's quadrant 3, here's quadrant 4. So now if I'm setting up sine in quadrant 3, sine of theta, I get a negative y divided by a positive r. Negative divided by a positive is a negative. If I go to quadrant 4, I'm going to do sine theta is negative y divided by positive r. Negative divided by positive is a negative. Okay, which makes sense. Sine is always the y values, and the y values are negative in quadrants 3 and 4. So that makes sense to me. Okay, it's the first time you guys are seeing it, so I understand if it doesn't quite make sense. Okay. Cosine of theta, I need to look at the adjacent over the hypotenuse. That's negative x over positive r in quadrant 3. And in quadrant 4, that's positive x over positive r. So in quadrant 3, cosine's negative, but in quadrant 4, cosine's positive. And again, cosine is the x values, so it makes sense that the x values are positive in quadrants 1 and 2, or 1 and 4, and it makes sense the x values are negative in quadrants 3 and 4, like that's what this is showing here, or 3 and 2. That's what this is showing here. And then the last one, tangent. In quadrant 3, tangent of theta is negative y divided by negative x. And a negative divided by a negative is a positive. So tangent is positive in quadrant 3. And in quadrant 4, you have negative y divided by positive x. A negative divided by a positive is a negative. So that's how you would determine the sign of each function. And when I say sign there, I mean whether it's positive or negative. I don't mean the trig function sign. That can be a little confusing from time to time. But we can determine whether a function is positive or negative. Okay. So now, what we're going to do here, I'm going to ask you to evaluate without using a calculator. You're going to need to take a function and figure out what quadrant it's in, and then we're going to evaluate that trig function. So before I start, I don't have the other circle with me right now, but you're going to want that circle from worksheet 16. I'm just going to draw my own. Okay. $180 and $240. And or 270, yeah. And then I had a 30, a 60, or a 45, and a 60. And then I want to put my radians in as well. I had 0 radians and 2 pi radians. 30 was pi over 6, 45 was pi over 4, 60 was pi over 3, 90 was pi over 2, 180 was pi, 270 was 3 pi over 2. And now, if I need to use this table, I will use it. But I'll start with tangent of negative 240 degrees. So I'll draw, first thing I need to do is I need to draw my angle and center position. So this is using a lot of the skills that we've learned the last week. And I'm going to rotate negative 240 degrees. Negative 90, negative 180, negative 240 is going to put me somewhere in quadrant 2. Now I need to ask myself, what's my reference angle? What's my theta prime in there? So theta prime is going to be that angle right there from the x-axis. And I can go ahead and say I went how far past 180? Another 60 degrees. So it looks like theta prime is going to be 60 degrees. Remember, it's always a positive number between 0 and 90, so I always have that when I'm looking for my reference angle. So that's the first step. I need to find my reference angle. The next thing I need to do is I need to figure out what is tangent of 60 degrees. Because that's what I'm thinking of right now is tangent of 60 degrees. And tangent is going to be my positive y value over, in this case, my negative x value. All right. So what I want to do here is I want to go to mod 5 when we had those tables where we evaluated trig functions. We did sine, we did, what was it, 30, 45, and 60, and we did sine, cosine, and tangent. And that was from mod 5. So this is like going way back into our notes now. But what we did is we had exact value answers from those special right triangles, the 30s, the 45s, and the 60s. And that's what makes those triangles so important today, is we're going to be putting it all together to try and figure out these angles. So sine of 35 or 30 degrees was 1/2. Sine of 45 was root 2 over 2, and sine of 60 was root 3 over 2. Cosine of 30 degrees was root 3 over 2. Cosine of 45 was root 2 over 2, and cosine of 60 was 1/2. Ooh, and then tangent. Tangent of 45 was 1. Tangent of 30, I'm blinking on it real quick. Let me draw a triangle. 30 degrees, we're going to say 1/2 root 3 over 2. So tangent of 30 is root 3 over 2 over 1/2. So it just becomes root 3. Because it's going to be root 3 over 2 times 2 over 1. So I'm putting all my math skills together. You guys don't need to have all your math skills together. You just need to know where to find this information on your old papers. Okay. And then if I'm doing tangent of 60 degrees, I'm doing 1/2 divided by root 3 over 2, which is 1/2 times 2 over root 3. And I'm going to get root 3 over 3. All right. So I need this table here. So I can say tangent of 60 degrees is square root 3 over 3. All right. And then the last thing I need to do is I need to say, what quadrant am I in? I'm in quadrant 2. And in quadrant 2, it turns out the tangent is negative. It's not positive. Tangent is negative in quadrant 2. So my answer for this whole thing, tangent of negative 240 degrees, which puts me in quadrant 2, is actually going to be negative root 3 over 3. It's a negative value, not a positive value. That's really, really weird. I'm going to give you guys a chance to work on these too. Don't worry. But that's what's going on with these types of problems. We're taking a lot of skills from both Mods 5 and Mod 6, and we're putting them all together today. All right? We're going to be quizzing on this on Tuesday, but we have a review day on Monday. That's what's happening with this part today. We have to be really good about these types of problems. All right, problem B, we'll look at one more example here without using a calculator. This one says cosecant of 17 pi over 6. Each trig function has exactly one co, and I know this one is cosecant. So this one's going to be buddies with sine. So what I'm going to do first is I'm going to figure out what sine of 17 pi over 6 is. Okay, I'm going to do sine instead of cosecant because I like using the traditional trig functions instead of the reciprocal ones. And we'll talk about how to do cosecant at the end here. First, I need to draw 17 pi over 6. I know that if I were to start rotating, here's 0, and then 2 pi radians is a full circle. If I want to put 2 pi in terms of something over 6, I could rewrite it as 12 pi over 6. That's 2 pi. And then I know this is pi. I could write that as 6 pi over 6. That's the same as 1 pi. And then I can tell that I'm going to do a full rotation. So I'm going to go 17 pi over 6. And if I subtract 12 pi over 6, I would still have 5 pi over 6. So that kind of gives me an idea of where I'm rotating. So I did 17 pi over 6, I went 12 pi over 6, and I'm going to need to go another 5 pi over 6 to get to my terminal side. That's quite a bit there. All right. Another way I could think about this that could possibly be easier is I always try and convert 2 pi into like 12 pi over 6. And then I would convert this to 18 pi over 6 and then 24 pi over 6. So that way I know that's going to be 3 pi and 4 pi and just keeps rotating around. And since this is 17 pi over 6, it's going to stop short of 18 pi over 6. So it's going to stop in quadrant 2. And now I need to find my reference angle, angle theta prime. Because I'm forming a triangle here. There's my triangle. It turns out that theta prime is pi over 6. Okay. Now we can get down to it. We want to evaluate sine of pi over 6. So this 30 degrees, that's the same as pi over 6. I have it right up here. So sine of 30 degrees is the same as sine of pi over 6. Pi 45 degrees is pi over 4, and 60 degrees is pi over 3. So sine of 30 degrees is 1/2, or sine of pi over 6 is 1/2. So it turns out sine of pi over 6 is equal to 1/2, which means a coterminal angle, 17 pi over 6, is also equal to 1/2. But the last thing I need to do is I need to check the symbol in my quadrant. Hey, sine is positive in quadrant 2. So that means this is going to be a positive 1/2. So sine of 17 pi over 6 is 1/2. Okay? But I wasn't actually solving for sine, I was solving for cosecant. So I have to do the reciprocal of 1/2. And it turns out the reciprocal of 1/2, cosecant of 17 pi over 6, is 2/1, or just 2. So the answer for this one would be 2. All right, that's a lot. That is a lot to go through. But we're going to practice today. We're going to practice more on Monday. We're going to get you guys ready for the quiz. Okay. But what I need you guys to do, because it says say evaluate without using a calculator, you can definitely use a calculator to check your answer, but like if the answer is like √3/2, your calculator is going to give you some weird decimal and you're not going to know what that means. So you have to be able to do this by hand, and you have to be able to show me work to support it that I know you're doing it by hand and not just putting something in your calculator. So make sure you know how to show me these steps. And right now I want you guys to